Hey guys, Chris from the Ultimate Recycler. Welcome back to the channel. Now, about 6 months ago, I reckon it'd be at least 6 months, I went to a garage sale, and we do it quite often, but with COVID and everything, we haven't done it as much as we'd like to. We love the whole, treasure hunting at garage sales bits. Even though we kind of don't have to for our businesses, it's good fun. So yeah, we sneak around when we can and check them out. Now, at this sale, I bought a little tub of jewellery. Here it is. I'll show you a bit closer in a minute. It was very cheap. The lady said it was just all junk costume jewellery, and it sells quite well in the shop. It doesn't have to be good quality. So I didn't argue, didn't haggle the price, gave her the money, no problems. Didn't think much more of it. But I did think there might have been a couple of good bits in there, and I even suspect there may be a bit of gold in there. Now, I had my glasses, but I didn't have a loop with me. It's a bit hard to make out hallmarks, especially when you're at a garage sale and you want to sort of scan across the trestles pretty quickly. You don't sort of spend 10-15 minutes checking out one piece of jewellery, because then you miss out on all the other bargains. Turns out I got a really good deal. We'll go through it in a minute, but this video I'm actually going to introduce a method that anyone can use at home for establishing if you've got genuine gold jewellery or sterling silver jewellery, as opposed to fakes. And there are lots of fakes around these days, and some of them are even hallmarked. So other than acid tests or other things, there's a really simple way of checking called checking their specific density. So we'll have a look at what I've got, and then we'll test a few pieces. Okay, let's look at the spoils. There is some very modern, chunky costume jewellery. Some of it's clearly novelty items. That's a skull ring. It's probably an aluminium or something. So there's clearly junk in it, but the whole lot was super cheap. The lady didn't want much for it. I just snapped it up because I thought, well, there's probably $10 there, or at least $5, so multiplication effect, it's going to work out quite well. There was a few bits here that I thought might have been good, and you do occasionally pick up 9-carat gold and sometimes even 18-carat gold jewellery. People forget where they get jewellery from, and it just gets mixed up, and I'm quite happy to take advantage of that, especially at a garage sale where someone's decided what price they want for it. So I grabbed it straight away thinking, yes, there's definitely some profit in there for my shop, and we'll look at it further down the track. And I didn't realise until I got home how well I did. So I've just reorganised it a little bit so you can see what's there. Clearly all this stuff on this side is modern, junky costume jewellery. These ones were actually magnetic, and I was about to say before that the first thing I do is get a nice strong neodymium magnet from a computer hard drive and use it to check. That brooch has a large clasp on the back that's clearly just steel. So the first protocol for checking your jewellery is a magnet, because there's a lot of modern chains and things that are really just plated steel, and if you can sort them out quickly, you don't even have to worry about hallmarks, because clearly if it's magnetic, it doesn't matter what hallmarks on it, you don't have precious metal. Okay, so I've sorted these out a little bit. These ones are going to be like $5 to $10 each in the shop. I might get a little bit more for that brooch. It's still nothing special as far as precious metal goes, but it's quite a nice one. I might get 10 for that. So those things are all going in the shop, and I'll do really well on my purchase price just on that junk, and we're left with some really good stuff here. Now, I've kept this one aside as well. It's actually junk. In fact, if you look closely at it, it's actually copper. You see down the base there where it's worn? It's just plated copper. So that's really junk as well, but I'm going to actually include that in my tests because it should be interesting to see what results we get. This one here is a named piece, and it is marked sterling silver. Now the name, I don't quite remember. I'll have to zoom in on that in a minute and have a look. But I don't think that will be junk. It's marked 925, and the top, even though the top looks like marcasite, I don't think it is. But that's better than a $5 ring. I'll check the name. I have checked on eBay, and they sell from $30 to $50 thereabouts second hand. So that one I won't eBay it, but I'll put that in the shop for maybe $30. So what we've got left is gold. These three here are marked, I think they're marked 9 carat, and that one's marked 3.375 or 375, which is 9 carat again, and same with the bracelets. So it's all 9 carat gold according to the hallmarks. But the point of this video is to prove that. So what we're going to do is set up a little test. We're going to weigh these, and I've also brought in a couple of other pieces of jewellery that I've had in a drawer for a while. I think that one's silver. There's no marks on it, but we'll check that and see if we can establish if it is silver or not. And this one is actually stamped, I think it's stamped WD18, and we'll get a close up of that mark in a minute. I think it's 18 karat gold, or white gold, or plated gold, but we'll do a specific density test, or specific gravity test as it's known as well, on that one, and see if we can establish what the metal is. So what we're going to need is some scales and a container of water and a piece of string or fine wire. Here we go. I've collected my materials. We're right to do some testing. Your scales do need to be fairly accurate, so if you can have some that go to 2 decimal places, that should do the trick. I mentioned this test is fairly simple, and it is, but it's a little tricky to get accurate, so we'll address those concerns as we go. I have a jar full of water. I have some very fine wire here which should do the trick. The items I'm going to test, and I'll only do a few of these on video, but I've written down some notes here of which ones we'll run through, and also some specific gravities of various metals. Now, I mentioned earlier specific density. It's actually different to specific gravity. The density is the mass of something compared to its volume, whereas a specific gravity is actually a ratio between one item's density to another item's density. So it's normally referred to like water, and that's what we're going to use the water for, and that will relate to these figures I've got written down here. So the first thing to do is to weigh the items, get a dry weight of the items we're going to test. We'll start with one of these bracelets, so our scales are zeroed out, and we've got 1.47 grams. That looks pretty stable. This little plastic barrier around the scales helps stop any drafts or air movement affect the weight. 1.46, let's write that down, and I'll weigh the others up. Now that we have all the dry weights of those items in grams, it's time to bring the water into the equation. So we'll put our jar of water on the scales and tear that out. Now, if you have scales that only weigh to, say, 500 grams, half a kilo, you might need to use a plastic container. I've just got a jar here. You can get away with a bit less water too. You just need plenty of room to dangle the item in it. So we'll tear that out. I'll try and keep the reflection off the screen. So that's 0. So now we're going to take this bracelet again, and it's on a very thin piece of wire, and we're going to dunk it in the water and watch what the scales do. So there we go. We have a reading. Now what that's actually measuring is the water displaced by the bracelet. So that's about 17 mil of water, and because 1 mil of water, it's not 17 mil, but 1 mil of water equals 1 gram. So it would be about 0.17, 0.18 of a mil is the same in grams. Now I mentioned that it's a little tricky to get accurate with this test, especially on bracelets, chains, and some rings, because they trap bubbles of air, and that will contribute to the amount of water displaced. So we're not going to worry what the scales do at the moment, but I'm going to jiggle it around, and you can see some bubbles of air coming off it. And once we think we've got rid of all the air, we'll dangle it in, not touching the sides or the bottom, and we'll get a fairly accurate reading from that. So 0.15. Interestingly, when we take it out, remember we had it teared with just the water, but now we're minus 0.08. That's because the water that's actually still on the bracelet. Now, there may not seem to be much, hardly anything. But just as the bracelet had bubbles of air on it, it comes out with water in those, between those links, and it's changed our weight of water. So you have to be accurate. You need to be accurate with what you're doing to get a good result from this. But you saw what we did and got rid of the bubbles of air. So now we'll write that figure down, and we'll do the same with all the other things we're testing, and including, we're going to have to shake this chain around a fair bit because I think that'll hold a lot of air in there. The plain ring and coins are the easiest because they don't really trap any air bubbles anywhere, and you get a really accurate reading first up. So let's write down the rest of those figures. And here we have all our samples and all our figures. So I've written that down as volume. It really doesn't matter if it's milliliters or grams because we're just after a ratio of these figures. So we've got the dry weight of the item. We've got the volume of water that it displaced, which gives us the volume essentially of the item. And we divide the 0.15 into 1.46, and we get a figure over here of 9.73. Now it'll vary a little bit depending on how thick a string or wire you use, because that obviously will alter the volume of water displaced. Also, I think technically the water needs to be at about 4 degrees because it does change its density according to temperature, and it's certainly warmer than that tonight in my shed. But it's only negligible differences. We should have a reasonably accurate figure here to compare. Now, if we scan up to what 9 karat gold should be, it should have a specific gravity of 11.16. So something's wrong there, and I don't think there's anything wrong with my measuring or my calculations. I suspect now that I certainly didn't at the start of this video that that's not real gold. Likewise with the ring with the stone. Now also the stone is going to change the figure because the stone will have a different specific gravity to what gold does, but it's only a very small stone and our figures are still way off 11.16. The ring with no stone should have been pretty accurate. It's a little higher, but it's still not really in the ballpark for 9 karat gold. The 18 karat gold ring I did, we had a specific gravity of 15.96, which is very, very close. 18 karat, 15.51. So I think this test has proven that that ring is 18 karat gold. Now 24 karat gold I think has a specific gravity, if I remember correctly, of 19.3. You really don't find anything heavier in jewellery. Gold is certainly one of the heaviest minerals. The silver chain was interesting. I did get a lot of bubbles of air off it, and eventually we settled down with a pretty accurate weight or volume there of 0.98. Gave us a figure of 8.49, and sterling silver should be 10.36. So I know it's not sterling. There's a chance that it might be a 50% silver. We'd need to do an acid test on that one, but I know it's not sterling silver. Usually silver is stamped if it's sterling, and that one wasn't stamped. And the last one for a bit of interest, I thought this was copper. Now it's clearly plated over the top, but you can see on the back of the ring there it has a coppery sheen to it. And I thought, oh yeah, that's copper. We'll do the test and see how it shows up. Well, our figure came out to 6.85, our specific gravity, and copper is 8.96, so that's a long way off. And I thought, well, that's weird. I'm sure I'm testing things accurately, and it should be a pretty good test on this. There's no other materials. So what I did is I filed, and I'll see if I can zoom in here. I filed what I thought would be copper, and it's silver underneath. I think you can see that little cut there. So I would suggest that, well, obviously it's not copper, and with a specific gravity fairly light, I would say that's probably some sort of die-cast alloy or some sort of muck metal, and then they've copper plated it because the top plating, whether it's nickel, I'm not sure what the top plating is. I don't think it's silver because it hasn't tarnished. But I know they sometimes use a copper plating over a base metal to then plate the final plating over the top of, because copper is a very versatile metal like that. So there you go. This test proved to me, I would have thrown that in the copper bin. Or actually, I probably would have sold it for $5, but had it been damaged, I would have sold that as scrap number 2 copper being plated, when in fact it isn't even copper. So hopefully that gives you a bit of an idea of how accurately you can test things using specific gravity. You do have to be careful, as I say, and there is issues when there's foreign material involved. It's much easier with plain rings. Certainly with coins, you can prove if you've got fake coins or not. There's a older style 9-carat gold ring I did here, and it's a nice rose gold, clearly stamped underneath 9-carat, and it is genuinely, and that figure worked out almost perfect. Now, as for these other things, well, these bracelets, we had 3 of these, remember? And even though they're stamped 9-carat or 375, they're actually fakes, and they're very good fakes because I thought they were gold. They are a little bit brighter yellow than you normally see gold. There's the other one here. And also these rings are the same brighter yellow. It's a bit hard to tell under this light in my workshop. But here's another ring that I found that is 9-carat. You probably can't really pick it through the phone, but it's got a slightly different hue to it. But what I did to prove it, I haven't actually got an acid test kit here handy. I've got an old one, but I think the acid's out of date. But a recent present I bought myself to start doing some watch repairs is this digital microscope. And I've put one of the bracelets just on a latex glove here, and I've put a little bit of old acid on it, and it was enough to show, if you can see that all right, that was something to point with. I filed this bracelet across this area and across that link and across there, and this certainly shows, the acid certainly shows that this bracelet is not 9-carat gold. It's plated, but it's not, the base metal is certainly not gold. I don't know what it is, but it's, well, I can say it's actually a fake, and it's a very, very good fake. And I did some checking. These also have hallmarks of an Italian goldsmith, as well as saying the 375. And I found some of these exactly the same on eBay, and the seller was asking about $185 each, saying 9-carat gold Italian bracelets, and they looked identical to this, and I'm pretty sure they're fakes. So there you go. I'll finish this video up now, but I'm going to buy a proper current acid test kit to test some things as well, and it'll be handy for maybe the silver, and it will be handy for some of my gold pieces that have more involved stones and things that it's a bit hard to work out the specific gravity. But I hope that's taught you a little bit on how you can prove your precious metal and prove that they hopefully are not fakes. Have a bit of a play with it, and you'll soon find that certainly in my shop I turn up a lot of old bits of broken jewellery, and sometimes there's bits of chain that are broken off, and usually chains only had a little tag at one end with the hallmark on. So if it's a bit of a broken chain, I may have some real gold here, and the best way to tell is with a specific gravity test, and then maybe just confirm with an acid test. So okay, we'll leave it at that. Thanks for watching, guys. I hope you learned something there. I actually have learned a bit doing this video, and I've also learned that I didn't do quite as well at this garage sale than I initially thought I did. I thought I had nearly $700 worth of gold. But as it turns out, the lady was probably right when she said it was all junk jewelry. Maybe she knew it was faked when she bought it. Don't really know. But anyway, it's good information to know. I'm more aware now when I'm out buying, and I now have a way to confidently test all my scrap gold and bits and pieces lying around. So we'll leave things at that. Thanks for watching, guys. I appreciate your support. I'll catch you in the next video. Bye for now.